Welcome back, my fabulous algebra students. So far we were talking about how to identify how many solutions any quadratic equation that we make in standard form has, whether kind of looking at the graph and with this thing called the discriminant. Well, the discriminant is part of a bigger formula known as the quadratic formula. What the quadratic formula allows us to do is if you have an equation that's not factorable or not easily factorable, let's say I have x squared plus 7x minus 2,962. I don't want to factor that even if I can. I don't want to go through all the factors of 2,962 and determine if any of them add to 7. Negative 2,962 and add them to 7. What the quadratic formula allows us to do is it allows us to find the factors, whether or not they are integers or they just allow us to find it without having to worry about factoring. So if it is easily factorable, factor it. It'll be a lot faster because it's not necessarily fun to plug things into the quadratic formula. But if it's not easily factorable, you can always use the quadratic formula, or you can use it to check answers. So there are many different ways to solve standard form quadratic equations. Factoring, completing the square is something we haven't looked at, but it's another thing you can. And the quadratic formula, however, can solve all standard form quadratic equations. Obviously, unless it doesn't have a solution, but then it'll tell you that too. So the quadratic formula says if a quadratic equation, ax squared plus bx plus c, is equal to 0, then x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Let me break that down. So, x equals, I'm going to start by this. Instead of calling it negative b, I'm going to call it the opposite of b. So the opposite of whatever is written in front of the x term, the x to the first power term. Then this symbol here is called the plus or minus symbol, because what it really means is we have two equations. We have one that's negative b plus the square root of b squared minus 4ac over 2a, and we have another equation where it's the opposite of b minus the square root of b squared minus 4ac all over 2a. So that's what the plus or minus symbol refers to. Then we have our square root of, and this part should look familiar. This is our discriminant. And no, I'll break down why the discriminant matters later too. So that's our discriminant. And then we divide whatever we get up there by 2 times a being that part. So, and here's really why the discriminant determines our answers. If the quadratic equation solves for this, or solves using this, the square root of b squared minus 4ac. The square root of any positive number, like let's say 9, is going to give us 2 answers. Because what it's asking is it's asking the question, what squared equals 9? And there are 2 answers to that. Because there are 2 things that can be multiplied by themselves to equal 9. 3 times 3 equals 9, and negative 3 times negative 3 equals 9, because a negative times a negative is a positive. So, when we take the square root of 9, we have 2 answers. We have positive 3, and we have negative 3. This is another place where you can sometimes use the plus or minus symbol. But if you take the square root of 0, there's only one answer, 0, because 0 times 0 and negative 0 are the same thing. The issue is, if you take the square root, and I'm going to move down here, the square root of a negative number, like -9, what that is asking is what squared equals -9? Well, the issue is, right now, with the numbers that exist that we've used, there's not an answer to that question. Because let's say we take 3 times 3. That would be 3 squared. 3 squared is 3 times 3. Well, a positive times a positive is a positive. If we take -3 squared, a negative times a negative is a positive. So right now we have no way of multiplying the same number by itself to get -9. And so that's why when our discriminant is less than 0, there are no real solutions, because if you're using the quadratic formula and you try to take the square root of a number less than 0, i.e. a negative number, you won't get any solutions or any real solutions. Again, just as a fun preview to Algebra 3-4, there we introduce a new type of number that we haven't used in math before, just like you used to only use like the counting numbers 1, 2, 3, 4, and then at some point someone introduced negative numbers in elementary school, and then maybe they introduced fractions and decimals. We keep adding to the kinds of numbers we use in math. And in Algebra 3-4, you talk about what happens if you take the square root of a negative number, and we actually end up with what are called imaginary numbers. But that's beside the point. So literally for the quadratic formula, all we do is, if our equation is in standard form and set equal to 0, then we just plug this all in and solve it. So, or simplify it. So, first, let's start with this. I'm going to copy down the quadratic formula. Quadratic formula is negative, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. In our problem, this is equal to, everywhere I see b, oh goodness, that is not a highlight color that shows up. Everywhere I see b, or let's start with a. Everywhere I see a, I'm going to replace with -1, because I know that a is -1. So I'm going to leave space for everything else for a second and put in my -1 all over 2 times -1. Everywhere I see b, I'm going to put 2, because b is 2. So that makes the opposite of b, -2. That makes b squared. I could just write 4, but I'll write 2 squared for now. And then everywhere I see c, which is just hiding over here, I'm going to put 3. And I like to put these in parentheses. So, I plugged in. There should be no variables left at this point, because we have an a, we have a b, we have a c, so all of our variables should go away and become numbers again. Now we work on simplifying. So, PEMDAS says, first, we do our exponents. This is our exponent, so I'm going to square that, and I get -2 plus or minus 4 minus 4 times -1 times 3 all over 2 times -1. Then I'm going to go ahead and do all of my multiplication at once. So I'm going to do this part and this part. So I'm going to have -2 plus or minus the square root. All of this, -4 times -1 is +4 times 3 is +12. So 4 plus 12 over, this is a positive times a negative, so it's -2. And then we get 2 plus or minus the square root of 4 plus 12 is 16 over negative 2. I'm actually just going to start using the space for the problem below, and I'll figure out what to do with that later. So then, what does that mean? Well, next, I'm going to take the square root of 16, which is a positive number, so it should have 2 square roots. So that's going to be 2 plus or minus 4 over negative 2, which will simplify down to, you can either plug it into a calculator at this point as 2 plus 4 divided by negative 2, or 2 minus 4 divided by negative 2, or what I'm going to do is I'm going to simplify this by dividing both of these parts by negative 2. So 2 divided by negative 2 is negative 1, plus or minus 4 divided by negative 2 actually does something weird where it switches to minus or plus, because, right, if it was a positive and you divided it by a negative, it would become a negative. If it were negative and you divided it by a negative, it would become positive. You can really leave it as plus or minus, it doesn't really matter. And then I do the 4 divided by 2 part and get 2. So negative 1 minus 2 is negative 3. Negative 1 plus 2 is 1. So my answers are x equals negative 3 or x equals 1. So it's a lot of work, but really all it is stuff we did from first semester algebra, right? It's simplifying. It's using PEMDAS and simplifying. It's just a big old thing of simplifying. And then we have the special plus or minus symbol, which we take in mind at the end by making it into 2 different equations. 2 different equations. But that's it. That is the quadratic formula in a nutshell. So, what I want you to do is you can go ahead and try these 2 problems on your own. When you're done or when you're stuck, pause, so pause, do those on your own. When you're done or stuck, you can play, or you can just check your answers. I'm going to move it down so I have space. Oh, that didn't work. There we go. There's that one. Move this one down. Copy, paste. Okay. So, hopefully those went well. Hopefully you're feeling a bit more confident and ready for the homework, but let's look at this one. So this one, maybe you got stuck because this one has a little bit of a trick. When we're looking at which parts are which, just like when we did the discriminant, we have an A, we have a B, and we have a C. But where's our C? Well, if it's not written at all, if it's not written in front of something, it's 1, right? Because it's 1 times whatever that is. If it's not written at all, if that whole term's missing, then it has to be 0. It's plus nothing. So that'll help us out a little bit. So, the quadratic formula says, if we have it in standard form, check. Set equal to 0, check. Then, negative, or the opposite of b, plus or minus, the square root of b squared minus 4ac all over 2a is going to equal x. So, let's plug in our pieces. B is 2, so the opposite of b is 2, so the opposite of b is negative 2, plus or minus. I'm going to go ahead and do this part in my head, speed up the process a little bit. B squared is 2 squared, that's 4. I can do that. Minus 4 times a times c. That's going to be 4 times 1 times 0. I'll just write that out for now. And then that's going to all be divided by 2 times whatever a is. Well, a is this thing right here. So a is 1. So that's what x is going to be. So it equals that. Then I say, okay, let's simplify some of this. I'm going to simplify the discriminant first. Right, this part in here under the square root. So 4 times 1 times 0. Well, anything times 0, it doesn't really matter what 4 times 1 is, or negative 4 times 1 is. It's going to be 0, so we're just going to be left with 4. Because 4 minus 0 is, 4 minus 0 is 4. And then it's all going to be divided by 2. And then I'm going to go ahead and do the square root of 4. So either in a calculator, or I think to myself, what squared equals 4? 2 squared equals 4. And then I'm going to go ahead and go, okay, negative 2 divided by 2 is negative 1. Really what I'm doing here, let's show the middle step, is I'm taking this fraction and I'm splitting it up into 2 because it can have the same denominator. So I'm doing it negative 2 over 2 plus or minus 2 over 2. Right, negative 2 over 2 goes there, plus or minus 2 over 2 goes there, and that is going to equal negative 1 plus or minus 1, which gives us 2 options. That's either negative 1 plus 1 or negative 1 minus 1. So that means x is either 0 over here or negative 2 over here. And those are our solutions. And as you get more familiar with simplifying the quadratic formula over and over again, you're definitely not going to need to show all of these steps. This is kind of overboard showing all the steps. Like, maybe some of you plug it into your calculator here. Maybe some of you just do more steps in your head. But this is kind of as close as I can get to all of the steps. So now this one. This time I'm not going to rewrite the quadratic formula. I'm going to go ahead and plug the numbers into it. If you don't have it written down, you probably should go ahead and write this down somewhere already so that it's easy to access. And remember, this part's the discriminant. So, what is this going to be? It's going to be the opposite of b. b is negative 4, so the opposite of negative 4 is positive 4. Plus or minus the square root of b squared, negative 4 squared. Well, anything squared is positive, so it's going to be the same as 4 squared, which is 16, minus 4 times a times c. 4, actually I'll leave that blank. So, I think in my head, 4 times 6 is 24. That times c is 24 times negative 8, whatever that is. And we were subtracting that originally, but we're subtracting a negative, so that's going to be plus 192. Whoops. 192. And then I divide that by 2 times a, which is 12, because a is 6. So again, this is you seeing I'm doing a little faster already. Then maybe I'm ready to go ahead and maybe I'll simplify what's under the square root real quick to 208. Whoops, erased too much. But I think I'm ready to try and plug this into my calculator. So I want to take, because you can also do it this way, whatever 4 plus the square root of 208 is, divided by 12. So 4 plus the square root of 208 is 18.42, etc. I divide that by 12. I get 1.53. 1.54 if I'm rounding correctly. Over here, I divide 4 minus the square root of 208. And that gives me that x is going to be negative 10.42, etc. Divided by 12 gives me negative 0.87. And here's the thing, with quadratic formula, decimals are fine and in fact encouraged. Because here's something actually to note. If you're getting decimals, that means you couldn't factor, right? Because this in factored form would be x minus 1.54 times x plus 0.87. I don't know how you would have guessed that was the answer, but you might want to apply for some kind of genius grant if you do, because that's not easily factorable. That's why we use the quadratic formula. However, this one over here, if I look back up here at the original problem, this one actually could have been factored super easy, in my mind, because you can just factor out an x. This would become x times x plus 2 equals 0, which by the zero product property means either x equals 0 or x plus 2 equals 0. If x plus 2 equals 0, that means x is negative 2. So you can't you see? Here, I'm going to show the differences in the work. If you can factor, look at that little green blob versus, I'll highlight it in red, all of this. So if you can factor, I would say it's definitely faster to factor. But if you can't, you're not going to be guessing this. You're not going to be figuring this out magically. So the quadratic formula isn't as bad. Let's review one of our other examples. This one was also factorable. So although it had a negative in front of the x, and factoring with a negative there gets a lot harder, and we haven't really gone over that. If you're watching the Khan Academy videos too, you're probably getting some things mentioning that, but I'm less concerned about that. So, as a basic review of this lesson this week as a whole, sorry that I'm rambling, but we looked at the different ways. We can have one x-intercept, two x-intercepts, or zero x-intercepts. We looked at how the discriminant can determine that. And then we looked at how do we use the quadratic formula to solve any quadratic equation in standard form, but with an emphasis that if you can factor, factor. All right, I think that took me a bit longer than I wanted to, but thank you for listening. And if you need help with homework, you know where to find me during office hours. The office hours are a little bit different this week because of the Memorial Day. So please check the schedule I posted on Google Classroom. Thanks so much.